Hello, this is Irv Shapiro with MakeWithTech. And today we're going to look at a very different piece of desktop technology that we can use to make remarkable things. Many of the videos on this channel are about 3D printing. And 3D printing, as it says in the name, is really about making three-dimensional objects. The challenge with 3D printing is that it's relatively slow. So if you want to print a large base, or let's say you wanted to make a puzzle, which is not very thick, but has a fairly large surface area, it's going to 3D print quite slowly. So there are better manufacturing processes for when you have a large surface that you want to manipulate. And it really comes down to the difference between additive manufacturing, that's what a 3D printer does, it prints and adds material as it moves up, and subtractive manufacturing. Today, we're going to look at a remarkable new product. It's remarkable not because the technology hasn't been around for a while. It's been around for a very long time, but it's been very expensive and out of reach of most consumers. And that technology is a technology to do laser engraving and laser cutting. Now, laser engraving has been available in a very small format using diode lasers for $100 or so for a number of years. But it's really not very practical for a lot of things other than maybe very small signs or very small pictures, maybe a coaster. So let's go back to our example of a puzzle. So let's say I have a sheet of wood, or it could be a sheet of acrylic, and I go into a program and I draw out my puzzle, or I find a puzzle maker on the web, and I want to cut this out. Now, traditionally, the way I would do this in my shop is I'd go to a scroll saw or a bandsaw and I'd cut it out by hand. You could do it on a CNC machine, which is basically a wood router powered by a computer. It's noisy, it makes a big mess. It's not very nice. Now, many puzzles cut out industrially are done with lasers. But those lasers are $5, $6, $8, $10,000. All of a sudden, the technology has come down market due to some recent innovations. And Xtool makes a product, and they sent me this product completely free. I did not pay for it. I did pay for about $150 worth of various materials I'm going to try it on, but I didn't pay for the laser called the D1. And what's unique about the D1 is it actually has two diode lasers in it, each that produce 5 watts of output. It's the output wattage that's most important, that combine into a 10-watt laser that's focused on a very narrow spot. It's like if you take your garden hose and you make it a very small opening so you get a very sharp jet of water, that jet is much more powerful than if you make it wide. So the better you can focus the laser and the more power coming in, the better the output. So the folks at Xtool claim that this 10-watt focused beam can do the work of traditionally a 15-watt laser. So we're going to have a blast here together testing out this Xtool D1 focused beam 10-watt diode laser. That was a mouthful. If you want to learn more, just stay tuned and let's learn something together. Well, folks, I'm back from a couple days of experimenting with my first really prosumer, more professional laser. I've used a laser before. I have this small little laser I bought for about 120 bucks about 3 years ago that I've done a review of, I did a video of. In fact, if you go on Amazon, you'll see in that price range a bunch of these little lasers that engrave things the size of business cards. And many of them have the look identical, but they have different names on the front. And this was a toy. It was cute. I made some luggage tags, but it really wasn't practical, and it didn't change my ability to make things. However, the Xtool D1 is quite different. I spent the majority of the last 3 years talking about woodworking and 3D printing, three-dimensional projects. In woodworking, I do a lot of work on a lathe, clearly three-dimensional. I've talked about electronics on the channel, and if you want to learn more about all these things, please subscribe, click on the bell, share this video and others with people you know that might be interested in learning about how to make and create things. The Xtool D1 laser is going to be a wonderful addition to my lab and to my ability to teach you how to use desktop technologies to create. Now, Xtool, as I mentioned earlier, sent me this at no cost. However, I've spent about $60 on software, about $150 on various supplies I want to use with it. And I'm going to continue using it because it has been a good experience. So let me share with you what we're going to cover today. Originally, I thought I would cover a very wide range of materials: wood, leather, metal, acrylic, glass, round objects, flat objects. I'm going to scale that back a bit because I've learned that just as with other desktop technologies, whether it be woodworking equipment or 3D printers, you have to learn how to tune your processes, how to calibrate and adjust the equipment. And the same thing with this laser. It starts with the assembly. The assembly was not difficult. There's an assembly video online at Xtool, which is excellent. I recommend you just watch it on your phone. You go step at a time. You follow the video. The video is about 6-7 minutes long. If I was to reassemble this laser now, it would take me about 15 minutes. The first time it did take me about 40 minutes. I put a couple of the parts in incorrectly. I had to reverse them, change them around. You know, you're unsure when you're plugging in cables. I don't know about you, but I've been dealing with electronics on both a professional and an amateur level for 40 years. I'm still a little nervous the first time I turn something on that I assembled that I'm going to see a puff of blue smoke. Either way, the assembly went fine. It was very, very easy to assemble. You have to adjust the tension on the belts. Very easy to do. Not completely clear how tight they should be, but much like a 3D printer, you want them to have tension on them, but a little bit of give. Then I got to the software. Software is a little more complex. And the reason is there are really three options. There's an app for your phone, very easy to use, very, very simple, but you can't use that to set up the printer. There's a commercially available program called Lightburn. I bought a copy. It's $60. And it's sort of an industry standard in the professional laser engraving cutting space. And you can't use that to set up your laser. You have to use LaserBox Basic. Now, if you go to the Xtool site and you look around, you'll find there's actually another LaserBox, that's the Pro version, that's not compatible with this laser. You have to use the basic version. Let's assume you've gone to their site, you've downloaded LaserBox Basic, and it's on your machine. Next thing you need to do is you need to connect a USB cable. It's a printer-style connector on the laser. I think that's excellent, by the way. I think that's a very robust connector. You need to plug it into your laptop, your desktop computer. Yes, you need a computer to initially set this up. And what does the initial setup consist of? It consists of setting up the Wi-Fi on this device. There's actually a very large, relatively large antenna here on the back for Wi-Fi, probably because with the laser and everything else going on, it needs a stronger antenna. But you need to assign your network credentials to the laser via a computer. So let's look at the screen together. And I'm going to start LaserBox Basic. And now I'm going to turn on my laser. Now, unlike a 3D printer or some other devices, it's not going to immediately home to any location. In fact, when using it with LaserBox Basic, there is no concept really of a home position. It's where it's starting and where is it going to go? I'll explain what I mean by that a little later. If you upgrade to light burn, there is more of a home kind of position concept, or an origin position. So using LaserBox Basic, we're going to go over to the box that says Not Connected on the upper right-hand corner, and I'm going to say Configure and Add a Device. Now you'll see there was already something in here. It's because I did it before, but we're going to pretend I didn't. I'm going to select my device, and there should only be one device that comes up that says LaserBox, because you only plugged one in. And I'm going to click on Next. Now it's going to look for Wi-Fi networks that it can reach from your computer. I'm going to select the network I want to connect to, the Dr. Vax network, and I'm going to put in my password and select Connect. If everything's working correctly, it should come back in a moment and say Connect Successful. What that's done is it's stored those credentials in this laser. They're in this machine. So I can now disconnect from this computer and use it over Wi-Fi. That will allow me to use the phone application. The phone application is also called LaserBox. It's very basic, very primitive. It's more of a demonstration than anything else. It does have the ability to load an image and print it as a rasterized image, but doesn't have any real control over how that conversion is done. You'll see that control is important. If we look here, this butterfly was printed directly from my iPhone using that app. And at the time I didn't know how to line it up properly. I'll show you how to do that now because I understand it better. But it's very nice. And so using this in a classroom or in a library or with some children, that might be an interesting way to do it. But we're going to get to a caveat in just a moment. Okay, so now that I'm connected, let's go ahead and see what the steps would be to print something. The first thing I need is something to print on or something to engrave. And there's a difference between engraving and cutting. Engraving is a little easier. That's all you can do from the app, by the way. Cutting's a little bit more complex. Let's start with engraving. I'm going to start with I think it's a 1 millimeter or 1.5 millimeter thick piece of basswood plywood. And I'm going to put it under the red X. Now, that red X is the starting spot. I'm going to assign that starting spot on the screen to my image. I'll show you how in a minute. It's not home. It's not the center. It's wherever I want to start. So I can actually start there and move in all four directions. Or I can start there and move down. Doesn't matter. It's the starting spot. To get started, let's insert some text. So I click on Insert one time, Text one time, then I click on my workspace, and I type something, LOVE. Now I can click on it again, and I can drag the corners to make it a little bigger. If it's text, I can go over to the right-hand side, and I can pick a different face. Unfortunately, it doesn't show you examples of these faces, so you have to just sort of look through. So there's the word love. Pretty simple. I can make that a little bit bigger. And now we're ready to engrave it on this block of wood. How do we do that? Well, first select what you want to engrave. If you have multiple items, you can select them all. Then click on Engrave and set the material. We're going to be engraving in basswood. And because we're engraving, not cutting, we don't have to tell it how thick it is. If we were cutting, we'd tell it how thick it is, and it would set the power of the laser and the speed of the laser to cut all the way through. For engraving, it's only going to go down a fraction of a millimeter. Now I'm going to click on the little blue and white play button here. And you see the item on the screen. And before we do anything, I'm going to go back for a second. Let's click on the item one more time and it's 113 by 69. Make sure it's going to fit on our board. Let's see, 113. It will fit, but it's a little bigger than I would like. That'll take a little too long. So let's actually make it a little bit smaller for now. Select our item, go back to the play button. And now, remember I said you put the red X where you want to start? So I'm going to put the red X where I would like to start. And then I'm going to put the blue dot on the point of my graphic that is the starting point. Now I could put the blue dot in the middle like this, and then I could arrange my board so the crosshair is in the middle of the work product. That X has to correspond to where the blue dot is on the screen. Now I very often like to put it in the middle because then I can center my piece more easily. If I put it on the side, my piece won't necessarily be centered. For engraving, centering is important. If I'm cutting something out, I may want to put it on the side to use as little material as possible. Next, I have to focus the laser. There's no focus on this laser. It's a fixed focus laser. What does that mean? It means I lower the lever that's on the side of the laser. I release the knob and I adjust it so that it's just touching the surface of the material. Then I pull the lever back up. Now, it's positioned, it's focused. How do I make sure it's in the right position? I click on framing, and we'll see it's going to draw a box on the screen around the area where it's going to engrave or cut. Now I've positioned it, I've focused it. Next important thing, put on your safety goggles. Now I have glasses on. There is orange, a shield around the laser. You still should wear safety goggles. And that comes to the concept, the concern about kids, is that if you have children coming into the room or in a classroom, everyone really needs safety goggles on. Now I'm going to click on Start. Now, one more thing I didn't mention is you hear it's even noisier in here now because I just turned on my exhaust fan. Now, I generally am not going to be using this laser a lot in my lab, even with an exhaust fan right on the wall next to me, because it does give off a bit of smoke. I'm in a house. It's not a great idea. So I did most of my testing out in the garage. Okay, that just finished. So I'm going to move the print head out of the way. And here's our finished engraving. Actually, it came out quite nice. Now, let's try something a little more complicated. Well, I could use the insert option to draw things on the screen. But I'm more likely to use a real drawing program to do that. But I could take and try to engrave an image onto an item. And this program will automatically rasterize the image. So I'm going to drag an image onto the screen here. And this image is actually quite large. I'm going to make it quite small so it will finish quickly. And it doesn't really matter where I put it, because remember, I'm going to line the crosshairs on the product surface to the dot on the screen. This time I'm going to engrave on fake leather. And I've tried this before, so I know that this has a lower engraving temperature than real leather. Now first, let's see if I can find the center of this item. This is about 90 millimeters, so that would be about 45. I'm going to make a very light dot so I can barely see. And let's see if it's 45 in the other direction. Yeah, that's about center there. So I'm going to use that center point for my crosshair. So I'm going to put the crosshair right on that center point. Okay, now I need to set the power of the laser. Well, I know from experience that this particular leather-like material gets too dark at the standard leather temperature. So I'm going to select this here. I'm going to go to leather, and it says 50% at 100 millimeters per second. I'm going to actually change this to 40%, and let's see how that works. The other thing I know is there are different ways you can rasterize an image. That is, can take it from a continuous image to a set of dots. And a lot of people recommend the Stucky method for use with engraving. Okay, I have my image selected. I'm going to click on the Start button. Now let's move the dot to the center of the image to correspond to the center of the surface we're printing on. Let's hit framing to see if it's about right. Okay, we should be ready to go. Let me put on my goggles, flip on my exhaust fan, and we will say start. Okay, while that's printing, let me share with you a couple things. I apologize for the dark glasses. The first is that sometimes the Wi-Fi seems to be a little bit flaky, and so I've often connected on the USB. And in the application, you have the option to select the device by its Wi-Fi address or by USB. The second thing is, if while you're working in LaserBox, you start to type something somewhere and then you move somewhere else, it doesn't look like there's anything on the screen, but there's actually a leftover object somewhere on the screen, it's going to mess up your centering. So you need to sort of select around the object you're working on and delete anything that shows up to make sure that all you have on that page is the object you want to print. So with those two things, let's wait for this to complete and we'll come back and take a look at some more samples. Okay, our print's finished. I'm going to take off my glasses and move the print head aside. Actually turn this off. We're done with this for right now. And it's a little dark, but not bad. And so I'm going to wipe it off a little bit and see if I can get the extra ash off of it. And that makes it even a little bit better. I don't know if you can see here, still a little bit dark, and that's where experimentation is necessary for this process. So with that said, let's look at some other samples that I've produced. One of the other examples I made just with the LaserBox program is this lettering. Let's learn something together. And you can see here the impact of different fonts. So you're going to want to be careful about what fonts you use. Then I did something actually that came out quite nice. This is the MakeWithTech logo, and this is a different leather. So this material uses different temperatures, meaning different power levels and speeds than this. This one used the default ones, and it came out excellent, really excellent. I did some experimentation with first cutting out simple objects. I drew a heart, and then inside of the heart, I wrote Papa loves Cura, my granddaughter, a little gift for her. And I selected the heart first, clicked on cut. Then I selected the text items and clicked on engrave. So you can combine cutting and engraving in the same item. I took the MakeWithTech logo, that was the same one that was printed on this leather, and I printed on this block of wood, which is probably oak, and it's a much harder wood, so I used the default settings for wood. I probably have to increase the power a bit for this to make it a little darker, but this would make a very nice coaster. Finally, or not quite, because I have one more to show you, I tried this on a metal business card. And it came out light, but really quite interesting, quite nice. And the fact that this consumer grade laser can engrave on metal is impressive. And then finally, I just wrote out the word love, and I selected cut, and it cut out the letters altogether because the capital L was not touching the O. It was a separate piece. I literally just took a popsicle stick and hot glued it on the back to make this little sign that I can also use with a grandchild. So I had a lot of interesting experiences with this laser. I also tried cutting vinyl, the type of self-adhesive vinyl, and that worked well. You have to adjust the temperatures just right. I did not go ahead and try engraving on glass or using the rotary cutter. I'm going to leave that for a future video. So what did I learn today? First of all, I learned that Xtool makes a well-assembled product. Yes, they gave it to me for free, but this is a well-assembled product. I also learned that in spite of the fact they gave it to me for free, the software still needs some work. And the Wi-Fi on the device is less reliable than the USB connection. But most importantly, I learned that this is going to be a valuable part of my tool set here in the MakeWithTech lab. And I'm going to do many more videos about this particular device and how to combine it with 3D printing, three-dimensional objects, maybe hinges and corners and other shapes, along with flat objects, along with perhaps even a bit of electronics. I could see some interesting ideas for building games for kids by combining these components. Well, folks, I had a lot of fun making this video. I hope you had as much fun watching it as I had making it. If you did, give me a thumbs up. Go to forum.makewithtech.com to discuss this, to show me pictures. I'm going to post pictures of some of the things I made here. And also, you can go to models.makewithtech.com to find 3D printed models to print. And now I'm thinking of enhancing models.makewithtech.com to also be able to export SVG files that can be used with a laser engraver printing product. Thanks so much. Have a great day. Let's continue to learn things together.